Captions check. Nicholas, that's close enough. Captions check. Test 1, 2. Hi, Mountain Man. Be getting started here shortly. off to the races here. What do y'all think of the new getting started screen? I got stuff. I'm frankly quite a fan. It was a lot of fun putting that together. Let's see here. Here I am. Aha! Hiding in the bushes. Hee hee. Oh, good. Boat. Indeed, it is a boat, and it floats. And as long as I'm a semi, competent driver, it'll stay floating. I love it. In the beginning of the video, I didn't know what I was doing, and I crashed it backwards into the rock. But I'm like, nah, that's staying in. That's staying in. That really. Oh, that's really loud. There we go. Yeah, that really feels the vibe. What it's like to do some of this stuff. Like, nah, I like that. We're keeping that in. All according to the plan. What's the plan? There is no plan. Or at least so we think there's a plan. Oy vey. All right, so I don't know how many of you in chat can count, but I'm going to explain. Last time we did 30 days in space, I was working off of day 4. Yeah, don't worry, Captain. We'll just buff out those scratches. Yes, 100%. If it's you, please tell me it's the SpongeBob meme in your head, because that's 100%. It's just like, you're good, you're good. And you just hear the loud scraping. Yes, okay, fantastic. It makes me very happy. I am such a SpongeBob nerd. It's not even funny. That sounds like a lot of hoopla to me, frankly. But yes, I digress. Last time we did stuff with 30 days in space, it was day 4, which was cabin lighting. And we made a total of 3, count them, 3 LEDs blink. And since I want to stay on brand with this, there it is. I didn't unplug it yet. And I'm getting audio. You can still hear me. Fantastic. I forgot to check that. When I plug this in, I'm actually just gonna plug it in so I can review my words and stuff and things. Okay, our code. The code. Inner workings of my. Oh my God, yes, 100%. I feel that. That's how I feel about it too. Last time, we wired up 3 LEDs to the switch, and then I toyed around and played with it and made the green one blink, and it's blinking super fast right now. The day 5 is just more of a creative day to play more with the LEDs. I feel like I've kind of done all that I was thinking I was going to do with just the basic of just controlling LEDs and whatnot. I'm not saying that I'm planning on jumping over every creative day that's in this 30 days in space kit, but just for this one, I kind of felt like we did what we needed to, and I'm ready to move on to working with some of the other exercises. So with that, we're going to start off with day 6. We're jumping over 5, and we are going to do the time to fix the battery. And we get to play with the funky little thing called photo resistors. I'm gonna let the computer lady do a little talking, and then I'll give you my, king's piece on my thought process with all of this. And then depending on what time it is, I don't know, we might do a little more balloonarama. I don't know, we'll see what this evening ends up, holding for us here. But we're gonna start with this, because this is fun. This is a good time. Okay, so let me get us into the appropriate scene. I want that one. And now I'm over here. Hello, everybody. Yes. Okay. Now, if I do this correctly, and I deafen that input, we shouldn't get an echo. Please tell me if you hear an echo. I think I've got this correct.
morning, Explorer. Or is it evening? Who knows under this ocean blanket? Now, let's wipe that taxed look off your face.
Perfect, thank you.
Oh, well, that is your face. Oops. Get ready to tackle our next big task. We can't ignore this any longer. Our battery levels are going critical. Our hero experiments and shipboard lighting barely draw anything. But what's killing us is just keeping things warm. I've had to shut down sections C to F, so no more jelly parkour, I'm afraid. Our solar array, which normally bathes in glorious sunlight to charge our batteries, is as inactive as a frozen comet. It's imperative that we restore it. Luckily, our kit is equipped with materials that have been waiting oh so patiently to be introduced. Photoresistors. For our training purposes, it's enough to know that photoresistors also react to light like solar panels, but in a different way. Photoresistors react to light like summer flowers. When the sun rises, flowers open. When the sun goes down, flowers close. With photoresistors, when they receive light, their resistance decreases, allowing more current to pass, or higher signal levels as read. In darkness, resistance increases, choking current, lowering signal levels. We can use this to simulate our solar panels receiving sunlight. So, brace yourself, dear Explorer. Day 6 begins and we have a solar system to fix. Let's get to know our newest shining star, shall we? This little device is also known as a light-dependent resistor, or LDR for short. The resistance of a photoresistor decreases with increasing incident light intensity. In simpler terms...
Okay, before I let her continue talking, I want you to take a quick look at that little icon. That's exactly what it looks like. Any idea where you've seen this before? Because this is 100% something that is in probably every bathroom. That allows you to, see where you're going in the middle of the night, if that was a decent enough clue. Marinate on that thought.
When there's more light, the flow of electrons becomes easier. When there's less light, the flow becomes harder. Think of it as an electrical component throwing a more light, more fun party. Photoresistors are made of high-resistance semiconductor material. Whew! Try saying that 5 times fast. When light hits the device, it absorbs the light photons. This absorption process provides energy to the electrons, which makes them jump from their valence band of orbits to the conduction band. This leap means the electrons are free to move, thus reducing the material's
not a motion
resistance.
sensor. Try again.
It's like magic, only its scientific nature is backed up by empirical evidence and testable explanations. Essentially, a photoresistor is a sensor that allows us to detect light in the way that a solar panel uses it to generate power. They are the key component we need to simulate and fix our solar array today. Remember, they are small and sensitive. Treat them well, and they'll return the favor in kind, Explorer. Moving right along, let's delve into the slightly more complex topic, the concept of analog and digital signals. Do bear with me, Explorer, as this will be vital for us to understand our photoresistor readings. All right, analog signals.
We'll be fine.
These are continuous signals. Imagine a dimmer switch connected to a light bulb. The dimmer can be adjusted to any level between on and off, providing an infinite number of positions of brightness. This is like an analog signal where the values can fall anywhere within a certain range. In terms of microcontrollers, they are a bit more complex to handle due to their nature of being prone to degradation and noise interference. What this complexity does, however, is allow them to represent numerous amounts of information with the potential to provide more accurate and refined data. Unlike analog signals, digital signals are discrete and can only be in one of 2 states, which are usually represented by either zeros or ones, meaning low and high. Picture a staircase. Each step you take is a definite value. There are no in-betweens. While they might not be as smooth or precise as their analog counterparts, digital signals are highly resistant to noise and easy to work with in terms of programming. Most of our microcontroller functions, like digital write and digital read, work with digital signals. So, where do our photoresistors fit in? I'm glad you asked. The value they provide, based on light intensity, is an analog signal. It can theoretically be an infinite number of values. That's why, to read these values, we need to use a different set of functions that can handle this variety, the analog functions. But more on that when we dive into the code. In summary, remember, Analog is like a dimmer, continuous and smooth, while digital is like stairs, definite and distinct. Got it? Great. All right, Explorer. I know you've been wondering why, of all the many pins, we specifically chose the A0 pin on the hero board for our photoresistor. Well,
spoiler alert.
Let me break it down for you.
Analog.
You see, A0 is an analog pin. Now, our photoresistor isn't just a simple light or no light type of device. No, it's much more refined than that. It measures how much light there is. It's like the difference between asking if there's food at a party and asking how much food is there. I mean, a few crumbs of chips don't really count, do they? Anyway, because we want a wide range of values and not just a 0 or 1, we need an analog pin, hence A0. It's really as simple as that. Analog pins for analog devices, digital pins for digital devices. Well done, Explorer. You've digested all that analog and digital chit-chat pretty well. Now, let's shift our attention to the programming part of our task. And what do you know? We've got another new tool in our kit to introduce, the Arduino Serial Monitor. The Serial Monitor is one of the most useful tools we have at our disposal when programming with the Arduino IDE. Think of it as a window through which your computer can have a conversation with the microcontroller. In this case, our hero board. With the Serial Monitor, we can send data to the hero board and receive data from it. It can also be used to examine the...
It irks me that in this example, that was a male USB, and it was plugged into the very, very female-shaped USB port on the hero board. I want to be completely clear here. That was not the correct end of that cable to be plugged into here. I know it's just an infograph, but for someone who has to read electrical diagrams, you're kind of killing a brother. Just saying. As we continue.
State of variables to debug, which is the act of finding and removing bugs in our code, or, like we'll be doing today, to monitor the readings from our photoresistors. To access it, we'll need to start by including some code in our sketch to establish a serial communication. Then, when we want to take a peek at the data being sent from the hero board to the computer, we simply click on the Serial Monitor option in the Tools menu in the Arduino IDE. Ready to give it a shot, Explorer? Let's dive into the code and start using the Serial Monitor to get a sense of what our photoresistor is telling us about our power situation. We're going to start using some new commands today, starting with analog read. This function allows our hero board to read analog input signals, which is just what we need for our photoresistors. Analog read measures the voltage between 0, which represents 0V, and 1023, which represents 5V, and returns a corresponding value. In essence, when we use analog read, we're asking the hero board to take a voltage reading from a specific analog pin and translate it into a number we can use in our code. Reading and writing are two fundamental operations in hero programming, or any programming for that matter. When we read, we're taking data or information in. When we write, we're sending data or information out. In Arduino terms, reading is often associated with sensors or inputs, like our determined photoresistors. They read or gather information from the physical world, which is used to make decisions in our code. On the other hand, writing is generally associated with actuators or outputs, like LEDs or motors. We write to them to control their behavior based on the logic in our code. All right, Explorer, are you ready to put this into practice? Let's start with analog read and see what we can learn from our photoresistors. It's about that time. Let's turn to some instructional material that I was able to gather cached on the computer. I've also...
Thank you, but no thank you. That's where I'm gonna pick up. Haha! Bye to me. All right, let me see here. Turn that back on. Turn that back on. And here I am. Okay, fantastic. We got some stuff. Oh no! All right, let me try this again. It's maple dough. Oh no, that's the wrong kind of dough. Oh my god. Closed captioning, what are you doing? I mean, she does. Her wife would likely confirm that statement, but that's not okay. All right, Maple, 100% hon. I was telling another individual about the cool stuff you do, and they looked you up as Maple Doe as the closed captioning caught, and I'm like, well, I mean, she has cake, but like it's not that kind, you know. We get used the wrong kind. Super, yeah. I mean, yeah, you can make the noises all you want. I thought it was funny. Oy vey. Okay. All right. Yes. I am a goober. I am a goober spotted. This explains in great detail. But yes, we have our. No, don't do that. That will be very hard to explain if you have to go to urgent care. There was a funny robot guy on the internet that said bad things, and there was cake involved. I don't know how would you that would be a wild incident report. I don't even want to know what the paperwork on that would look like. That'd be absolutely wild, off the wall. We don't want that. I don't want that. Oh God. Ah! All right, fair. That's an acceptable amount of silliness. Oh, okay. So I had prompted the question while she was talking. Where would one see these little dudes, these photo resistors? The answer is the bathroom nightlight. Let me explain. So what we're gonna do is we're gonna read some values on this little guy using our hero board. And then we're going to use the programming logic to, I believe in this example, we're making the onboard LED blink at different speeds. I don't know, we're going to look at the code. We're going to do stuff and thing. Oh my goodness. Mountain Man. I don't remember what the name of the individual is, but there's a viral EMT. And his tagline is, please don't meet me like this. Honestly, that is 100% advice to live by, because if you wouldn't have one to explain to the EMTs, don't do it. I mean, there'd probably be a lot less videos on social media if that was the case, but it's pretty good advice to live by. The thought process is real. Oh, good lord. But yeah, bathroom nightlight. They have one of these little doodads in them, and when it gets dark, it reads dark enough in the room, it turns the light on. This is literally, I mean, it's a bigger version of a nightlight, but that's basically what we're gonna hook up. And that's what we're gonna do. Obviously, there's just a fairly basic microcontroller with all the extra, you know, plugs and ports. Like if you were to bust open one of those little night lights, you're basically gonna find similar circuitry. But yes, this is what we're hooking up. So let me get the wires plugged in where they need to go, and then we are gonna work on getting the code in this waggy thing. So let me switch scenes. I want that one. Aha! Fantastic. All right, look at that. And I've got chat. I'm taking you with me. All right. I have you there so I can see you. And we're working. All right, good. So this is our example from last time that I have for us. And this is a little recap before, because I'm going to unplug it, obviously. We have 3 LEDs. I programmed the green one, which is the first in our lineup here, to flash when the switch is in the on position. When the switch is off, it's just off. Now, all the other ones here, the blue and red, are individually controlled via the other 2 switches. And that is through the our little hero board that I have on the bench here. That allows the lights to blink in sequence. So I'm going to remove this, and then we're going to hook up the circuit that they gave us. So, as last time and every time, before I change any of the wiring on our board, first thing I'm going to do is I'm going to unplug it from the computer, so that there's no power in this general vicinity, which then we can start doing stuff. So, since this is a completely fresh build, I can disconnect all of these like so, because we're going to end up working with fresh code. So
the way this was programmed, when I reprogram it, it's just going to flush out what all of what that was up to. So there's that. Okay, we got that. Looking at my example, I'm not using either the grounding or positive rails this time around. So we're just gonna unplug these. And we're gonna be very careful to not break anything. That, a couple of those. And then if I remember correctly, I'm pretty sure these were all the same kind of resistor. The 225 ohm before I pull them out of here. Let's see, yes, and no. Okay, so I'm going to remove the ones for the LEDs and put them in one pile. And then I'm gonna have to put them in something to keep them labeled and disconnect the ones from the switch here. Now, looking at my diagram that we have lovingly in front of us, I actually need to hold on to one of these. And that is a 220 ohm resistor, and that is denoted via the colored bands that are on here, just like it is in the example. Hi Pyrex, welcome on in. We've got 2 red, 2 black, and then a gold. A little refresher, the way you read these is the colored bands from left to right, with the gold, silver, or I believe black, I think is the other color, on the far right. That indicates the resistance is futile. Thank you for that. That allows you to read it from left to right. So red is 2 2, black is 0, so 0 0. Or wait, no, double black. No, I thought it was 220 ohm. Well, looking at the diagram, I may have that incorrect, but that is the correct one I need, so I'm going to keep that one out. Yeah, I'm pretty sure. Wait a minute, I can look at it in here. I'm not nuts, right? That is 220. No, I did read that right. 220 ohm resistance, right? 220. Okay, good. I've got labels. Helpful. Yeah, gonna put that over there and finish getting these unplugged. Something always a little sad about disconnecting one of these after you had it all hooked up. That's okay, because we get to make more cool stuff. I'm here for that. All right, so we don't need any of our LEDs, so I'm just gonna remove them, and then I'm gonna grab the kit, and we're gonna clean a little bit of this up. Get myself oriented here. Don't need that. What are y'all up to this evening? Other than, you know, coming to watch my insanity. You do anything fun today? Or y'all just work? Or are you on your way to work? I mean, time zones, man. Those things are crazy. Everybody's everywhere and nowhere at once. Kind of nuts, to be honest. Alright, I'm gonna put those away. I got our photoresistor. I got that. I grabbed some jumpers. I need 3 jumpers for our example. Oh no! No, day 39 is a 7-day job! Wait, is this vehicle related? Because if it's vehicle related, that sounds like one broken bolt into a 20-minute project. That's really what that sounds like, which I am sorry for you in advance. That sounds horrific. Ooh, fairground stuff. Oh, that's awesome. Okay, so you're doing other stuff. Got ya. Ghost train ride. Ah, my God. Unbelievably steampunk. I love it. I love everything about that. Hierarchs, you do such cool stuff. 100%. I love that, like, the idea of, like, steam as transportation, like, has taken many different forms, and the fact that it still exists in something like that. Power grid. All right, that's fair. Yeah, it's fair. You know, just like, we're not letting go of steam. You're not getting rid of me that easily. All right, I need 3 jumpers. let's see, do I have those colors out already? I don't have to follow with the colors they gave me in the diagram, but it doesn't hurt. A black, red, and then I'm gonna use orange instead of blue. Why not? Okay, so something I like to point out that's not given in the example that our lovely lady gives to us. This is our little photo resistor. Is the legs on this particular component is the same on both sides. There's also no polarity to this, so there is no correct or incorrect way to hook this up into the breadboard. That's not something that they mention, but I'm going to continue to mention it for stuff that is important. And in the case of something like this, it's fine. There's no worries. Something like a capacitor, which, funny enough, I don't think our kit comes with one of those. No, it does not. Has a polarity, and if you wire it backwards, it blows up. Usually it pops, and you have a small little smoke ball in your face. So, probably a good idea they didn't include that in the kit, because if you don't know what you're doing and you hook that one up backwards, yeah, you're gonna get a face full of smoke. Not particularly good. What do we got here? Fun thing. Oh, steam engine to generate the power, though. Okay, you let the magic smoke out. You've got it, Mountain Man. That's 100%. That was the thing when I was learning all this stuff early on, is that you don't let the magic smoke out of the box, because once you do, you're gonna have a bad time. Okay, all the time, every time. That is just how that works. All right, so let's see here. Sticking along with the example, I think they put 2 spaces in between. I don't really care about numbers on this. I just need to make sure that they're not hooked into the same rail. So, I am plugging in the photoresistor in pins 12 and 15, just to give a little bit of spacing on it. Don't accidentally short anything out. 110 transformer with the full bridge rectifier, 110 DC. Oh, yeah, it's been a while since I've wired up a rectifier. That's a total of 4 diodes in a square pattern that more or less reverses the waveform to make it direct. Yeah, it's been a while since I've seen something like that. That's cool. Yeah, well, I mean, in all fairness, Mountain Man, anything that's incredibly high voltage like what you work with, yeah, that's not a little magic smoke. That's I cast fireball. I don't care how small the room is. That's pretty much what that boils down to. Let's see what we got here. All right, so one leg we're gonna hook up to the resistor. Like so. Power grade stuff is cool, but it's terrifying. When it's incredibly extra high voltage, you end up wearing the super fancy, like bomb squad looking suit. There's like usually a big, what is it, carbon fiber hook on a one that's that does not conduct electricity, that they put around your waist, so that they could pull you off in case something poor happens. So I think it's really neat, but let me tell you, that is not for the faint of heart. Gotta be careful with that stuff. All right, we've got our ground on one side. Please be safe. That's all I'm going to say. Please be safe while doing your job. All right, we got ground to one side of our 220 ohm resistor, and then it's sharing a leg with the photoresistor, and then we've got a lead here, and that is where we're going to take our reading, is at the left leg of our photoresistor, and then we're going to launch in our 5 volts down this rail. So electricity is going to flow in 2 different directions. It's going to come across the red wire into the photoresistor, and it's going to go all wiggly woggly across that, and then there's going to be a reading that's going to be taken on its path back to ground. Now, a couple things going on here. This is simply just a probe to check the voltage at the outside of our photoresistor. Now the reason that we have the regular resistor that connects us back to ground is because the more light that hits this, the lower the resistance that it has. So if it gets too low in resistance, it would actually be technically a direct short, which we don't want. We want to actually have a complete safe path. That's what this resistor is doing here. It's to complete the connection in a safe manner. So I'm going to hook this up to our little board, and then we're going to start looking at some code. And then we're going to hit this with some different lighting mechanisms. Potential divider there. Uh-huh. All right, let me get this in front of my face. I need to plug this one into ground, which is fourth hole down. So I'm holding it like this. 1, 2, 3, 4. Ground is right there. And then I need our probe, which is in this case orange, because I swapped orange for blue. I'm going to plug that into A0. Maybe, please. Yep. And then this lovely individual into 5 volts, which is 1, 2, 3, 4, fifth hole down. 1, 2, 3, 4, 5. All according to the plan. So I've got 5 volts. I've got the probe check, and then I've got our path back to ground. Okay. Now I'm going to plug. So yes. So in the video, I am going to bitch a little bit about this. This is what the cable looks like. And in the example, it showed this piece plugging in to the very not rectangular hole down here. This is a USB-A to USB-B style cable. So computer side, device side. They don't plug in the other way. They're keyed like everything else. Like, because we all know that when it comes to plugging in this end of the cable, there's only 3 orientations. There's wrong, then you look at it, and then you plug it in and it's right. That's 100% how these work. There will never not be a time that you get that plugged in on first try when you're not able to see the connector head. I'm convinced of this. Okay, something has crossed my mind that I did not do before I plugged this into the computer. And it will be fine. Normally, what's a good idea is to clear the programming on the board before hooking up a new circuit, but that's okay, because I am not using the A0 pin in the previous project, so the voltage is going to go through, and A0 simply will be ignored right now until I program it. It's always good to clear the previous programming off of the board before adding new stuff, and that was a little miss on my part there, but that's okay. I can plug this in anyway and get our connection going here, because to get the reading off of our photoresistor, this needs to stay connected, right? This particular project only makes sense with it connected to the computer before I make some changes to it. Let me do that. All right, so right now we've got a couple of LEDs on here, and that is going to be the on LED, which is the right one, and then I think that's the onboard LED. It's the far left one, which is just on. It's not set to really do anything special. I put the Ethernet port in. Yes, okay, that's all right. You're fair. You got me there. All right. No, hold on a minute. Let me think about this for a second. Do I have one of those handy? I do have one of those handy. All right, hang on a minute. No, we're actually gonna talk about that for a second. Because, right? Because I have one available here to me. Since you brought it up, there is an Ethernet port. There is a B style of USB. And if you've ever looked at the back of a printer, the plug that this is supposed to go into is usually right next to this one. And what people will tend to do is just push this into there because it kind of fits, you know, but it doesn't really quite fit the way it's supposed to. Like, I could probably force it in there and break my adapter, but I don't really want to do that. If you've ever looked at the back of one of those machines, yeah, this is not for this. These two are not the same. I've seen that more often than I'd like to admit. So there's that. Nope. See, look at that. Now I got it wrong. I have to look at it and flip it around. See, the laws, okay? The laws of USB was true because I didn't look at it and I didn't get it right the first time. I digress. Okay. All right, we are to the point that we have got power. We've got our photo resistor. Now I'm going to switch scenes and we're going to do some programming. So I'm going to take you with me. We can chat for a walk. I'll wander you over here. And then we're going to go back to
This one. Haha. Welcome back. It does fit well enough to like short the pins out together. Generally, it doesn't cause actual damage unless like it was actually forced in there and like bent the pins. If it's just contacting all of them together, almost anything I've ever worked on, that doesn't break it. It doesn't make it happy, but usually it's wired in a way that if all of them are shorted together, nothing happens. I'm gonna have to, you know, give props to those that make these devices to make it so that that doesn't have a bad time. 50% chance of getting it correct way around and getting it 100% of the time. Yeah, that sounds like the correct math for this absolute disaster on wheels. That's known as, you know, components. I'm just saying. Okay. Let's see here now. So the next thing I gotta do is I gotta fire up the IED. So we're gonna minimize that. Gonna fire up our friend. Okay, so this is... Ha! Listen, Arduino. If there was ever a time to want to update the application when I'm live is not the time. Not right now. I appreciate you though. You know, it's sad because I did check the laptop for update before I went live. I checked it yesterday to make sure that Windows wouldn't pop in. I forgot to launch the IED. I forgot it checks. Yeah, I love that. Because why wouldn't I want to update it right this minute? I mean, it probably wouldn't take that long, but still, I don't want to do that. Okay, so we are going to make a new sketch. Okay, and before I do anything, I have saved it, so any of the changes I make here as I compile will be saved in this new sketch. So first things first, before I do anything else, I'm going to connect to it. So we have to go to Tools, and then we got to go to Port 3, SECOM 3, and then if I do a verify on the code, it's just an empty project. I'm gonna send that. Building sketch, it's uploaded, uploading done. And then if we take a look at it, nothing has changed. And now if I hit the program button again, you'll actually see the blinking. That left LED is the one indicating that something's happening from the computer. So yeah. So we're now to the point that there is now no code or logic on that board right now. provided by us. So now it's back to default, which I may forget to do that, but I always start the project off the same way, you know, blank, so shouldn't cause any real trouble, but you know. 220 volts to, oh no, 110 circuit because you messed up the back feed. Ugh. No, no, don't do that. You'll live longer. That's unpleasant. See, that's like the little switch that's on the back of the power supply on a computer. There's the 220 volt and 110 volt setting on the back. Yeah, it's usually almost always indicated as a tiny red switch. Fun fact, Creality's 3D printers, not only do they have that little switch on the back, it seems that Creality's companies defaults the switch position to 220 volts. So if you're someone in America, you need to move the little switch over to 110. Now here's a fun tidbit about that, since you brought that up. Now, if I plugged my printer in or my computer, it doesn't matter, anything with that little switch on the back, and I'm in America and the little switch is set to 220 volts, and I turn on the power supply, nothing's going to happen because it's wired expecting the higher voltage. So it won't work. The computer won't turn on. Now, on the other side of that, if it was set to the American voltage of 110, and then plugged it into a European circuit of 220 volts, boy, you're going to see some lightning. Because it's now going and anticipating the less voltage than it's getting, and that's a bad time. Oh yeah, no, I totally believe that. There's so many devices that don't have that toggle. A lot of them, the power supply is just auto switch. So it can accept 220 or 110 volts, but the circuitry doesn't require you to physically maneuver a switch. On computer power supplies and the supplies that come with a lot of 3D printers, you have to physically move that little toggle. It's funny. So if you want to check if you have unburnt new power motor. Ew, that's no good. If you want to check and see if your power brick that supplies power to your devices, if it's capable of working at 110 or 220, look at the actual label that's on the power brick, because it will tell you acceptable input voltages and then what it outputs. Like a lot of the smart USB-C chargers for like Chromebooks or higher draw devices, you'll see that it accepts 220 or 110, and then the output voltage could actually be a couple different things. It could be 5 volts, it could be 9 volts, it could be 19 volts. And the reason that can have multiple output voltages is because the USB-C that you plug into the other end of the device has a conversation. It says, hey, what charging speed is safe for me to give you? And then that communication happens, and then it gets the voltage that it requested. But on a dumb power supply that doesn't have a conversation, it just puts out voltage and accepts voltage. That you have to be mindful of, because bad things happen. So I lead back to something I've said multiple times on this channel: do your research. If there's a little manual or pamphlet that came with the device, take a second and look at it. Even if you think you know it all, or you're familiar with most of the things, it does not hurt to take 10 seconds to look at that to make sure you don't lose your eyebrows. I don't have any eyebrows, okay? I got a HUD right here on my face. But 110%, you're probably going to want to keep them. Because if you lose them and you draw them on too high, you're going to look surprised. And no one needs that, okay? Keep your eyebrows, all right? That's what I'm going with here. Okay, we have this up, we have this connected. We need code. We need code to do cool stuff. Let's see here now. So I am going to pull this out in chunks. Work equipment is setting in the software. You have to flash if you've never had to switch 60 hertz to 50 hertz. I have not had to change the hertz of a circuit before like that. That's going to be kind of funky in the software, I would have to imagine. Yeah, let's see here. Okay, yep, same thing as last time. We have to include the library for the Arduino, and that line of code goes above the void setup. So the Arduino library is what tells the compiler what the pins mean and like how to use them essentially, and then we can just interact with the stuff. Oh no, that's not good. Alrighty, and then I'm gonna copy this. This is our declaration of our photoresistor. So it says here, our photoresistor will give us a reading of the current light level on this analog pin. So we can see here that we have a variable and its type is a byte. It's a constant, so it's declared as such as a const, and the name of the variable is photoresistor underscore pin, and it's equal to A0. Now, the reason we declare this particular variable as a constant is because this is declaring which pin that we're reading, and the pin isn't going to change. So this, we want to be a constant. We wouldn't want the code to have the ability to change what this variable does. We want it to stay equal to A0. Then the rest just kind of works itself out. The mains frequency to derive things sometimes for certain things. I mean, that's fair. I mean, I ever worked with 60 hertz at 120. There's also, you know, 220, and then there's the higher voltages. But again, keep your eyebrows. That would be the good idea. Alrighty, let's do a little reading here. What are we doing next? These two constants set the minimum and maximum delay times for our blinking LED. The type unsigned int represents numbers from 0 to 65,535. Another name you may see for this type is uint16 underscore t. We need this since these delay values can be greater than the biggest number a byte can represent, 255. So that gives us two constants for how slow or fast. I am not. Oh no, I'm a US bean. And that's going to go above our void setup. Now these are also constants, again for the same reasoning. We want our unsigned minimum delay and maximum delay values to not change, so that's why these are constant values. Oh no, I meant I don't mess with the having to convert that. I've only ever worked with 60 hertz. I haven't had to work with 50. I haven't had to try to do that. I think my camera lost me. Oh, there it goes. my head got real stiff there for a second. Okay, so we've got those items. All right, so in our first time setup, what are we doing? We'll blink our built-in LED based on the amount of light received from the photoresistor. So our pin mode of the LED built in is going to be an output, which makes perfect sense because we're going to blink the LED in some fashion. Oh, interesting. I didn't know that, Pyrex. Huh. I mean, again, I know that the world's power sources are different depending on, you know, where your power comes from and where you are in relationship to it. But that's cool. And then we have to declare our pin for our photoresistor. And that goes in our first time setup. So our photoresistor pin, that we declared up here, right? It's always, this variable is always going to be equal to A0. Down here is where we actually declare what the pin is used for, right? It's an input because we're reading the value of the photoresistor, so the input method has to be input. Our LED is just going to put out light, so it has to be an output. This is how that has to be declared because that's what their functions are. If we don't declare it that way, simply the code won't work. Okay, so now we're going to get into a little bit of reading here. To show you the exact value being read by the analog pin, our photoresistor, the exact number using our Arduino's IET serial monitor, this code that we're going to add here is going to display in the sketch the values it's getting from the hero board. Oh yeah, the UK power plugs are like equal to, if not worse than, stepping on a Lego. Exceptionally poor time. Especially if they're the 3-prong ones. Like, no, that sounds like a bad time. Okay, so what we're doing with this serial begin and this number is opening and establishing a serial connection to send data back and forth, right? 9600 baud is the speed of the connection. Now, that's incredibly slow in today's world. The only time these kind of speeds are seen is if you're doing something serial related, reading values or sending data. Yeah, they may be the safest plugs when they're in the wall, but if they're sitting on the floor, you know, good luck to you. I would want to step on one of those. I've seen what those look like. Yeah. Now the fun thing is that there's a lot of different serial applications that actually run at this speed. Like I've connected to Cisco switches. Yes, network switches, those things, the things that make the internet work. They have serial connections on them for you to be able to configure them when they don't have a functioning network connection. It's a fantastic way to unbrick one of those pieces of hardware. Most of the time you generally don't need the serial connection too often anymore on them, but for recovery purposes, they're fantastic to have. They're not fast though, so if you ever have to restore the firmware over a serial connection, just know it's going to take a couple hours. Okay, now we're going to get into our loop here. Each time through our loop, we will read the current value of the photoresistor. When the voltage goes up from more light, we flash the built-in LED faster with shorter blinks. So that decreases the time between blinks. The photoresistor will produce a voltage that is not a simple digital on or off. It's going to be a value between 0 and, what did she say? Oh, there it is, 1023, giving a full range of values. Because we are reading an analog value instead of a digital value, we have to use the analog read function, and we also have to use an analog pin. They are wired differently. How slow your 100K test set serial port is? Oh goodness. You know, I mean, there's so many pieces of equipment that still have serial ports on them. Now granted, they're not usually called serial ports in most cases. Usually they're referred to as console ports. It's same difference. And people wonder why you can still buy a USB to serial adapter. Yes, folks, the world still uses serial. Just if you're one of the lucky ones, you don't ever get to interact with one. In this case, it's for fun, but in a working environment, let me tell you, your mileage may vary. All right, so we're entering our loop, and we are reading the photoresistor to get a value. So as we've seen before, the void setup declares our input, output, and establishes our serial connection, to which then that's one-time setup, and then the void loop is what we run until either we hit the reset button on the little board or we lose power from the board. I'm not surprised by that. Isn't the OBD standard that cars use still a serial connection? I'm pretty sure that's the case. Oh yeah, you'll never find that. I did actually order a USB Type A to RJ45 serial cable online, and it's incredibly helpful. Instead of having to go from, yeah, I thought so. Instead of having to go from USB to DB9 to DB9 to Ethernet, it's nice to have just a cable that goes straight from USB to, you know, RJ45. The nice thing is that if you've ever seen a serial cable, it's usually denoted with a blue jacket on the outside of the cable. I don't think I've ever seen a serial cable that wasn't blue jacketed. Fun fact, they're wired differently than a normal Ethernet cable. Oh, let's see here. All right, so right here we're going to read from our pin the light value. So we're just simply reading the photoresistor's value. Oh, that's unfortunate. Yeah, I mean, if you don't know, if you don't have one of those cables on hand, I mean, overnight shipping is your friend in that case, but still, even then, that's a very unique item. It's troublesome for when they get their hands on one. Definitely not. Okay, so story time real quick. There was one of the times that I was in school, and I actually needed a USB to DB9 serial adapter. I I had a funny feeling that I wasn't gonna find one. But I figured, let me try one of the close electronics stores. Out of giggles, right? Just to see if they would have anything. I figured the answer was probably no, which is correct, but it equated to a fairly fun interaction because I went over to the help desk that they have in this place and I asked them, a fairly young looking employee, and I said, hey, I'm looking for a particular adapter. I don't know if you sell one of these. And I said, hey, do you sell USB to serial DB9? And they just looked at me like I was out of my mind. And I'm like, they just looked at me. I looked at them, and I'm like, obviously the answer's a no, but you also don't know how to respond to what I'm asking. To which then they said, hang on a moment. And they grabbed their manager, and the manager came over, and I repeated myself, and without skipping a beat, the manager's like, yeah, no, we don't sell those here. I'm gonna Google and show my employee what you're talking about, just so they know for next time, in a little education. But yeah, we don't sell that here. I said, okay, fantastic, thank you. And she just kind of gave me a little wave, and I'm like, yeah, we good. I ain't salty. I just, I didn't mean to cause problems, but I did anyway. It was such a deer in headlights moment, and I felt bad, but like, you're an electronics store, so I figured there might be a chance. Yeah, no, it wasn't a good move. Wasn't a good move on my part. Okay, noted. Boop. All right, let's see here. Yes, I am taking the long way around to this. Okay. So we've got the next part of our loop here is when we interact with the serial port. Okay. So short of getting, I don't need these tabbed, these are on the same line. Short of getting our value from our photoresistor, when it's stored in a variable, by default, we can't see it because it's in the variable, right? So we need to present that to the screen so we can see it, right? Under normal circumstances, when you have something that just runs by itself like a bathroom light. You don't need to see serial output, right? But for testing purposes, like what we're about to do, we want to see what those values are to make sure that we wired this correctly and that it's working as intended, right? So serial print is the command that will make those values appear in this little black window that we have down here. We're going to get those values. And it's going to say the light value, a colon, and then there's a space in here, and then the ending of the quote. If we don't add that space in here, then the number would be stuck right up against the quote, and it would be a little harder to read. So that space is there intentionally to make this more legible. And then serial print is the light value. Now, I don't know if there's any carriage return lines, so I don't know if they're going to be on separate lines or if it's going to go right on the same line. So we'll see what happens here when you run the loop and see what it ends up starting to spit out. Yeah, we'll see what we get there. A serial port cereal. Okay, that just sounds delightful. See, now that sounds like something I would see in a knockoff cartoon or the background of a knockoff video game. like Cereals, you know? But it's the best cereal full of packets. Like something like that, something extra goofy. That's immediately what I think of. Alrighty, and then we are cooking. With a couple of additional static unsigned numbers. We've got the darkest light value is going to be equal to a light value. This is the lowest value that we have in the photoresistor. And then the brightest light is going to be also equal to light value. Right now, on first run through this loop, these are going to be equal to exactly the same, right? And looking at our code here, those weren't inside of braces or anything, right? So that's actually going to run exactly as it is. Oh no! Attacked by an ad. Oh, that's rude. The packet choke is perfect. I mean, right? Pyrex, I use it for transforming testing. Okay. Fair. Lowest value returned, right, and then I'm going to read through this because the way this is declared is a little unusual to me. So the flashlight varies based on the relative brightness of the photoresistor, right? That makes perfect sense. However, your brightness level could be very different if you're in a dark room from running this in a very bright sunny room. Because of this, we will save the darkest value and the brightest value seen. These values will normally be lost when each run of our loop ends. Oh, okay. But by adding the static declaration, we indicate that these local variables should maintain their value between the loop runs. The first time these variables are used, they will get initialized with the first light value, but the initialization is only done the first time, so they will retain any changes between the loop runs. Okay, I was wondering because I was thinking that the way this is laid out, that when the loop runs a second time, that it would just equal to the same thing again. I don't know. I'm still a little confused by the way the syntax is laid out on here for this, but we'll see what happens when it runs. We could do a little debugging. I mean, that's the way it's written. It's very strange. So normally when you equal one variable equal to another variable and it's in a loop, right? Under normal circumstances, on the next run, that variable then gets equal to what's on the right, if there's no condition that prevents it from being modified. So the way this reads to me is that the darkest light would always be equal to the light value regardless, but from what the code is telling me in the comments here above it, that's not what it's going to do. Now this is the logic I was looking for, but the fact that that's there and that's in the loop, right? I'm not nuts. I mean, I'm nuts, but yeah, it's in the loop. So that means that every time the loop runs, it's going to spit out the value to us so we can see what we've got. And then down here, we're storing it. Right, and then we run some logic against it. So if the light value of what we currently have is less than the darkest light, then the darkest light is equal to the light value. If the light value is brighter than the brightest light, then we set it equal to that. I'm so confused by this static unsigned. That doesn't make sense to me and why it's declared like that. But by adding the static declaration, we declare that these local variables should maintain their values between the loop runs. They will get initialized with the first light value. But that initialization is only done the first time, so they will retain any changes between the loop runs. I don't know, we'll run it, we'll just see what happens. I don't like the way that's written. Now that's simply just the way the syntax is that I'm just obviously not super familiar with. And we'll add that over here. Oh boy, my favorite. Now we have an interesting problem. As our voltage reading goes up, we want the LED to blink faster, and thus with a smaller delay. In addition, we need to adjust the blink rate in a noticeable way. So we have one range of numbers, the darkest to brightest values, from our light sensor, that we wish to convert to a different range that goes from max delay down to minimum delay. The Arduino language provides a neat function named a map. This was created just for this situation. It takes a value from one range and it maps it into a desired range. It properly handles the situation where the second range goes down when the first range goes up. We introduce its use here to map our light value, which goes from darkest light to brightest light, and return a value from max delay down to minimum delay. Perfect. If you say so. Interesting. So we're going to throw this in here. I want to kind of dissect it a little bit. It sounds reasonable. And I mean, I'm picking up what it's saying by the mapping, right? Because our values from 0 to 1023, which is a full 5 volts, right, from our reading, well, our blink, as we declared up here, we want between 50 and 500. So what it's going to do is it's going to take that range that we have of 0 to 1023 and then map it between 50 and 500. And then it just does the conversion for us. That makes sense. So let's see how that's actually written out here. So what we do is we have the delay value, right? So that's another unsigned integer, which means it'll change. And it's called delay underscore value. And then we're mapping stuff. So we're taking the value, the light value, right? So if we take a look here, our light value is what we're reading. Yeah, I'm Pyrex, I'm right there with you on that one. I didn't know that there was a map function into the Arduino suite, but hey, look at that. That's why we're doing this. This is cool. We're taking our value straight from the photoresistor and we're storing it in light value. And then we're taking the darkest value that we got over multiple. So every time this runs, it's going to retain the darkest value. And then we'll also take the brightest value and then we're mapping that. So darkest to max delay and brightest to minimum delay, right? Which I understand why it says it's backwards, right? So if we hover over this, let's see what we got here. So it says constant unsigned value 500 for max delay based on being in the darkest of light. And then a minimum delay for the most amount of light, which makes sense. As it had said in the example in the video, is that the more light we get, the faster we want the light to blink. So we would want the least amount of delay for it to blink faster. Because what's faster, a delay of 100 seconds or a delay of 10 seconds? Faster would be the 10 seconds. 100 seconds would take longer, so we would be also blinking slower. So that's taking two very different values and switching them around by the way that the map function works. That's really neat. Okay, so then we then ask, after that we've got the delay value based on that map function that's built in, which is super cool. We get our delay value, right? And this is then presented as a printout to the screen so we could see it in the little black box down here. It'll literally print a comma. Okay, so there's no enters between any of this stuff, which means that this will say light value, there'll be a space, and then the number, right? And then next in the serial print is a comma. And then it'll say delay value with a space in between, another space, and then the actual value that it generated, right? So that makes this legible. Now, I am going to look up here to see how we add a carriage return or an enter between lines, because I would like it to be spaced with enters instead. I'm going to have to look that up though, because that's not a part of the example, but I think that'd make this a little more legible. Okay, and then finally, we then blink the LED based on the value we get. So now we blink our built-in LED that's on the board, right? So digital write, because it's a digital input, it's either on or off, right? The LED that's built in on the board. Now, this is a defined LED built in. If I scroll back up here, I didn't type that anywhere. It's not declared anywhere. That is a piece of code that is a part of the include suite. I don't need to write anything out to declare that I want to use the built-in LED. LED underscore built in is just the variable name for the built-in LED that's on the board. There's nothing special you need to do to declare that. It's just there. Yeah, exactly. It's hard-coded into the chip. We're going to turn it on, and then we're going to delay based on our delay value that we got from our map function. So we're going to take the reading from the photoresistor, and then we're going to convert it into a delay, and then we're actually going to delay that amount of time. We're going to turn the LED off, and then we're going to delay again the same amount of time. So that allows us to actually see the blink on and off in a meaningful amount of time based on the light brightness that we have in the room. Okay, I'm going to save that. I'm going to compile the sketch and verify it to make sure everything looks okay. I didn't add any typos. I did not introduce any typos into this. Now I haven't sent the code yet, right? So without sending the code, I'm going to show you the board before. Our built-in LED is the one on the left. And that one is currently solid red right now. It's not doing anything. That would be that LED right there. That's the power one right there. You can ignore that one. That photoresistor that's sticking up out of the board that's almost impossible to see because it's so small, which is right there, is going to make that blink slower and faster depending on the light. So let me push the code from here. We're gonna send it! It's gonna be a full send. Upload! Buckle your seatbelts! Turn on the Weather Channel! All right. Okay. Small problem.
I don't see any input to the terminal. I see blinking. It is doing the thing. We are going to play with the photo resistance.
But we're supposed to be seeing something in the terminal here. And we're not seeing that. I wonder why we're not seeing that. Am I supposed to do something for that? Houston, we do have a problem. I don't, because I thought that would have showed here, unless I'm supposed to actually... Ooh, serial monitor. See, yep, thank you. I didn't realize it was a separate monitor for that. I should actually be able to pop this out, I think. Can I, like, pull it out? I can't. It's not gonna let me. Is it a right-click context thing? I would rather actually make this a separate window if you'd let me, please. Clear output, toggle timestamp, toggle auto scroll. No. Come on! I want that. Alright, fine. So, not allowed. Alright, so right now, the light value, as we can see here, is an 84, right? So that's not very bright in comparison to what is considered the maximum number that this will have based on brightness. So we're not blinking that fast. We have a delay of between 200 to 300 milliseconds right now, right? So if we take a look at the light, we're blinking, right? But we're blinking at a fairly steady rate. Now, as advertised, if I put my hand over that little sensor, it's blinking slower. And if I move my hand, oh boy, we got a light. We are off to the races. We're going real fast. We slow it back down. And speed it back up. And slow it back down. And speed it back up. Now we're going to go back to here. Right, and now I'm going to do the same thing again, but I'm going to show you the terminal this time. So we're going to slow it down by covering it. And there is a value of 17, 18, right? And our maximum delay in this example is 500 seconds, right? And you can see that that's pretty darn close to 500 milliseconds. Right, and that's 100% going to calibrate the darkest right there. And then I'm going to move my hand out of the way. And the light value in the room is back up into the 80s. Now, you're 100% correct by noticing that it changed how fast it was blinking, right? Oh, we are gonna do the minimum and maximum. That much I can tell you. It's about to get very slow and very fast with this. Right, so, but it was cool though, right? Because I'm gonna reset the code, right? So I'm gonna go back to over here, right? So to reset the darkest value, I could tap that reset button on there, right? And as long as I keep my fingers away from the photoresistor, that's gonna slow down again. That is cool, isn't it? I think it's really neat. Now you can see how slow it's going right now, right? Now if I go back to here, the value is exactly the same. I didn't change anything. The light in this room right now is exactly the same, and you can see that. I could prove that the light value is in the 80s again, right? But the speed that it's blinking at for the delay, right, isn't that harsh. So if we take a look at
our LED, it's not blinking that fast. The delay is fairly low, right? So I think this will also work the other way too, that I'm not going to cover it, I'm going to add more light. Right, and I'm going to do that with a multi-intensity flashlight. And we're going to see how slow or fast we end up blinking here. So I've got this set on a low-ish setting. And our light value is reading at about 160. And then I'm going to go up a level. My light value is in the 600s now. Up another level. I'm now in the 600s. Right, get a little more on with it. Maximum brightness! Yeah, now our delay is so low, it's a little hard for you guys to see, but the value of the light value in the terminal is in the 800s right now. If I kind of go a little more top down on that without blinding myself, I just blinded myself. I'm close to 900 now, and it's blinking really, really exceptionally fast. Oh, I had another light level above that. Let's go! Oh god, oh, it hurts to look at that. It's so bright. I'm glad you guys can't see how this is blinding. Boop. Now, if I remove my flashlight, my light values are back into the 80s again. That's the ambient light of the room. Right now, I want to see what happens. Yeah, right. It's like this flashlight. It hurts. It hurts to look at. You're not supposed to look at it, but that's just what can I say? Interestingly enough, by making it exceptionally bright in the room, it's blinking about the same speed as when I just fired up the program. Now, what do you think will happen if I cover it to give it an exceptionally dark value? You think it's going to speed up again because we gave it more brightness? Do you think that's going to change anything at all? Because I think what's going to happen when I cover it, that it's going to speed up again, and it's going to, because the negative, the dark value is going to be increased. So I think that's going to cause this scale to slide. Yeah, Pyrex, I'm with you on that one. I think that's what's probably what's going to end up happening here, and that's what we're going to do. I'm going to cover it, my finger. And then we've got a light value of about 15, 16 in the terminal. And I'm going to move my hand. And interestingly enough, I don't think it's going that fast. It's about the same, interestingly enough. Huh. It's a little faster, but not by much. So by defining those really high value, those upper and lower thresholds, it's more of evened out the blinking speed, which makes sense. That light was incredibly intense. And to show you guys the terminal side of that, right? I'm going to attempt to make this a little bit bigger. My head's in the way, of course it is. All right, well, I can at least do that. I don't think I can make these any bigger, can I, on the serial monitor? No? All right, well, I apologize. I don't know if there's a decent way for me to make this larger, but that's at least should be somewhat legible. I'll at least slap it in the middle of the screen. I'm going to hit this with darkness. Right? Our light value is in 14, 15, delays at 500 milliseconds. Oh, Mountain Man, if you want one of these things, it's a Fenix PD36R. These flashlights are absolutely amazing. FENIX. Here, I'll actually put that in chat. I'm not sponsored. I just like their flashlights.
ED36R. That is the flashlight that we're toying with here. It's nice because it has an on and off switch on the back. The intensity is the switch in the front of the flashlight, so you don't accidentally switch back and forth between being on and blinking on and off rapidly. Oh, it's actually not too unreasonable for a flashlight. I want to say this was about under $100 for it, and it uses a removable lithium-ion battery. Let me see which battery this uses. It is a 21,700 battery, so 21,700. It's a 3.6 volt lithium ion, but they're fantastic. I use this flashlight every day. And the battery life on it is so nice. Now I'm gonna hit this with the flashlight again so you guys can actually watch the terminal or the light value go up in intensity, because I want you to see it. I thought it's just kind of neat just to see the values, right? So I am on the first intensity of the flashlight, so the light value is in the 4/500s, and then gonna do intensity 2. We're at 800s. Intensity 3. Intensity 4. Intensity 4 is at around the 900 mark. Remembering that our full value is 1023. The next intensity above it, let's see if we can break 1,000. I mean, we're not breaking 1,000, but we're pretty close. It's definitely bright in here. Okay, so I have something that I very much want to try. I'm hoping it's charged. I'm gonna grab a pointer laser. I want to see what the light intensity actually reads on this with one of those, because a laser is a very, very, very tightly packed beam of light. So I would think if we're going to come close to breaking 1,000, we probably can do it with one of those. We're gonna try. We're gonna try. I don't know what's gonna happen, but we're gonna try and see what happens. Yeah, the brightest was over 900, going from 80 to 14. Yeah, it was a bit of a tiny change, right? Because the scale slid. That's a really good point, Pyrex. Hey, by all means, Mountain Man. I mean, these kits, they're available. I think they're fun. Again, I'm not sponsored. I just like playing with fun stuff. Let me grab my laser pointer. I think I know where that sucker's at. Just a moment. Oh, hi, Pyro! Welcome on in. Okay, I'm back. And I have the laser pointer. So, for context, this is a 5 milliwatt green laser pointer. You can use one of these to point out a beam, you know, or point out anything at really just about any distance. The reason I'm going to say that is because this type of pointer laser I could use to point out a constellation in the sky. Okay, as with any pointer laser, never point it at a person, never point it at a living creature, and most importantly, on top of all of that, combination of the two, don't point them at aircraft. You will get in so much trouble if you point one of these things at aircraft. You don't need a license for them, but you have to at least be reasonable with them, because you can get yourself in a fair amount of trouble with the feds. So don't do that. Oh, the light sensor for your Proot. Oh yeah, 100%. I like that. Oh yeah, no, the FAA will ruin your life 100%. And they don't care. They do not have a sense of humor. I want to express to you the level of not having a sense of humor that agency has. There are Christmas displays that you could purchase. That's like this beacon of laser. It's like multiple laser diodes in like a housing that you stick in the ground outside of your house that goes through a diffuser that causes that LED, or excuse me, that laser light to be deflected, and it makes like a shower of laser on your house, right? That's low enough wattage, it won't hurt you if you get caught in the eye by it. But there was a elderly couple that had one of these things in their yard. They just stuck it in the yard. That was it. They plugged it in. It looked pretty. The neighborhood loved it, right? Well, here's the problem. The laser light that was coming from that device stuck in the ground that they probably paid about $30 for at a big box store cleared the roof of their house. So it was actually sending laser light into the sky. They got in trouble with the FAA because aircraft were getting laser light into the sky. And they weren't doing it intentionally, but cops came and banged on their door and said, hey, don't do that. Thankfully it was a mistake, and they were chill enough to, hey, like, turn it down so that it wasn't shooting into the sky. But I kid you not, don't mess with laser pointers, because the FAA, they are not nice people when it comes to that. They care a lot about safety, but yeah, don't do dumb stuff. You know what? Out of context or with context, yeah, don't point that at airplanes. I'll take it. 110%. All right, so now the cool thing I get to show you, I'm really hoping my camera can pick this up, is the intensity of this laser. All right, so I'm going to turn off the lights in here for a quick second so I can show you the absolute madness that we have here. This is a beam of light. Echo, turn off Team Rocket. Oh, that's right. My monitors are going to cause light. That should be all right. I'm just going to close the lid a little bit on that. And I think I could turn off this display. I want to get this room. Oh, the power button's locked on this monitor. That's right. That's okay. I still think this will probably show up on stream. Stream probably didn't lag, but it was probably my camera kicking in. Yeah, so I'm gonna try to get this as a nice angle and shoot this across the camera. Yep. Now that green reflection that you're seeing kind of going in and out is the laser pointer that's whizzing across the face of the viewfinder. You know what? Let me see if I have something reflective. I think that will probably help with that. Give me 1 second. Because it kind of puts into perspective. That should put into perspective what the laser actually looks like. So if I put this in front of here, like such, and I tilt this slightly. I mean, technically, I think if I bounce it, I don't know, if I bounce it off of there, would that actually make it easier to see? Maybe. Short of running it through a piece of conduit. I like how ironic that is. I am transmitting data via light, in the most ridiculous sense there is. I mean, if I hit the table with it, like so, we do have that, right? But if I do something to that effect,
then hit with that with the laser. Nah, it doesn't really come across. This is one of those things I don't have a decent way to show this. I'm gonna hit the lights back on though so I can see what I'm doing. But I digress. I'm gonna hit our little sensor here with the laser, and then we're gonna see what happens to the values, because I don't know. That value, 437,574,000. Nope, I didn't read that right. Yeah, close enough. That's a big number. That's bigger than any of the numbers we have available to us. I am curious to see what happens here. I mean, you're kind of not wrong. All right. So listen, I think on the fly, and this kind of comes back to another thought I had, is that if I were to point this laser into networking equipment, I kind of want to have an idea of what it would do. Like, it's not going to obviously be able to establish, link, but I mean, it would, even better idea. Oh, Tosh link. Okay. All right. I am scattered-brained all over the place here. All right. So audio equipment. All right, so this is going to have to be for another time. I'm going to have to see if I can get my hands on one. Audio equipment that allows optical in, right? So, like, what if I just shined a laser into the optical in on a speaker? What would that would sound like? Because it would technically be like, the blinking, because that's how it, like, sends the audio. I don't know. It may make no noise, or it might shriek like a toaster. I don't know. All right, I'm getting sidetracked. I want to hit this with the laser pointer. I'm going to try not to blind myself. Carefully. I am kind of blinding myself. Alright, so I'm gonna hit this. You guys are looking at the bench right now, so we're gonna see if our light blinks faster or slower or something in between. The values are at... No, we're definitely blinking faster, and we're at about... If I can keep this on there. No, I'm only getting to about 600. It did not go as high as I thought it was going to. Interesting. I want to show you guys that too. So we're going to switch that back over to here so I can show you what I am seeing. There we go. I'm not gonna lie, it's a little hard to line this up, because I have to look at the piece of equipment that's mildly reflective, so I'm kind of partially blending myself. This is not easy to do, I'm not going to lie to you. I get it without looking at it, which that's like trying to plug in a USB right the first time. Survey says this is bright. There you go, 600. That's a little hard to do. Not trying to blind myself. Effectively trying to already do it. Echo, turn on. Yes. Okay. Ba-ba-da-ba-ba-ba-ba. Alrighty here. I mean, all right. So, I'm not gonna lie. That's 100% something I probably should be doing, but that's also part of the reason why I only owned 5 milliwatt pointer lasers, because that is the highest you can go without causing retinal damage if you accidentally get it to bounce off of something and into your eye. I know enough to not potentially injure myself. If you do end up having something that's, higher than that when it comes to laser safety, yeah, you definitely want the glasses. Now, speaking of laser safety in networking equipment, the lasers themselves are interesting in the fact that you can't just buy one pair of glasses to prevent yourself from getting eye damage when it comes to laser pointers or lasers in general, because laser technology is in different spectrums, right? Now, the spectrum that I have is a green laser pointer,
and that has a spectrum value. I don't remember what it is. And that requires glasses that block that spectrum, right? Now, if I had a laser pointer that was ultraviolet, which gives off a very mild purple color, the spectrum would be different. So I would need different lenses to protect from that spectrum. Same thing with high intensity red lasers. It's the same story. You found my emotes. Yo, that's right. I forgot. Guys, I have emotes now. Feel free, spam some of them in chat. They're actually, maybe don't spam too many of them. I'm a little scared of the auto mod. Pyro, save anybody who accidentally spams too many. I don't know if I have anything that would do bad things. I hope not. All right, no, we're good. That's looking okay. Yeah, we have some fun stuff in there now. You could think the absolute amazing Asset. Asset makes all of my awesome emotes. He did a really good job with them. Am I a bad broadcaster? Please tell me I put him in my yeah, no, I did add him. Yeah, he's in my art credit on my channel description. He's my artist for emotes. Because he's made my emotes. I love them. They're so nice, especially the spinny Roomba one, which I'm gonna put in chat myself because I like that one a lot. Ooh, spin me right around, baby, right around. I love that little emote. But yes, it's Xenor, how are you doing this evening? Coming in to join my madness with technology and little fun things. No worries. I tried my best to put all the ones I thought that were the best emotes in the free slots. But Asset, Asset's a mad lad. Well, Pyro, who is that? Does that clear that for stream? Oh, okay. I just missed it on my dash. I don't know if that disappears for everybody else. Which, actually, here, let me try. You got me curious now, because if I had cleared it correctly. Okay, well, hey, hopefully they do good stuff since we accidentally shouted them out. Let's see here. Okay, no, so it didn't cancel it, because it's telling me it has to wait another 20 seconds before another shout-out could be given. No, that's fine. It's okay. Accidents happen. No worries. But yeah, the whole laser thing. There's higher intensity lasers. Okay. That's fine then. That require special glasses, all right, that prevent you from essentially getting blinded from if you get a stray ray or a direct shot in the eye via one of those laser pointers. The thing is that if a laser's intensity rating is high enough, and you're not wearing proper protection to protect your eyes, you could just instantly go blind. Especially for the laser pointers that are infrared, or those that fall on the higher end of the light spectrum that are beyond visible light. Because here's something that is a bit of a scary thought. Your eyes blink when bright light is shined into them. That's exactly how that works. if you have a laser of a high intensity that does not give off any visible light, but it's the higher end of the light spectrum, your eyes aren't going to blink, which would help reduce damage done to your eyes. Your eyes aren't going to pick up that fact, but they're still going to get damaged. So if you're ever in an area that deals with laser light and it's high intensity, whether it's visible or not visible, invisible is infinitely more scary than the visible stuff because you can't see it and your eyes can't blink, which could, lead to permanent blindness. So yeah, definitely wear the appropriate equipment when it comes to that. Thankfully, like I said, my pointer laser is just low enough on the spectrum that you'll get a little spots in your vision if you get clipped in the eye by it, but it's not going to do any real damage. Obviously don't stare into it, that would be bad, but push goes to shove, that's what it is. I mean, listen, I don't have any receivers, okay, for laser light technology in this brute, so I'm safe for the most part, but I can't say that for all the toasters. I can say it for this one though. Push comes to shove. Okay. Let's see what time we have here. We got a time. All right. I think what we're gonna do. I'm gonna switch us up to Putt-Putt's Balloonorama. I kind of want to see what some of the more difficult levels of that look like, because we're about done with this particular activity, but I'm down for us to stick around for a little bit. So give me a moment while I switch up our scene here. I'm not surprised by that. Laser, so the fact that laser light itself is such an intense light, it can damage the camera's optical sensor, because of how intense it is. So there's that. Okay, so I am going to save our project. I'm going to shut down the presentation computer. Don't worry, I'm not going to shut off the wrong machine. Or am I? Hopefully I don't. I'd still like to be here. I'm gonna disconnect from that. And I'm gonna close that. Beauteous. Now the fun thing is that when the laptop shut off, the power to the USB ports was also severed because the computer isn't on. So if I show you the bench right now, I didn't disconnect any of it yet, but since I shut the computer off, the power to our little board has been removed. So all the values that were stored are now gone. So that's something. Oh, infrared would be cool with the DSLR. Oh, that would be a lot of fun. Give me a moment. I have to update stream element stuff. Put that in there. Clear that. There we go, I got that, and done. Okay, so we got that. I've switched us up to Balloonorama, so I'm in the right category. I will look that up after stream, Senor, but I think that's pretty... I mean, I like playing with DSLR. Yeah, can you do that for me? I'd appreciate that. Curious to see what that looked like. Alrighty. Oh, that's really cool. Huh. Neat. Alright, let me get that back off my screen, and I'm going to thank you. I appreciate that. Go to my library. I mean, I've seen some of the deep space stuff before. That stuff's always really neat. We're getting there. Oh, the sounds of nostalgia.
Hang on tight to those balloons, Pep. Uh-oh. Come on, Pep. We've got to go get those balloons.
Alright, I need to... that. Okay.
Hi, I'm Putt-Putt.
Oh, that's not the right
Welcome to
button.
Balloon-O-Rama. Are you ready to play a game? If you want to start at the very beginning of the game, you click on this button here. If there's an old game you want to keep on playing, all you have to do is click on this button. And this is really
Hi,
great.
Ro. Thank you for
You
the
can make and then play your
resub.
own levels. This is where you click when you want to build new levels. If
Do I
you
really
want to
not
make
have the alert
changes
box
to
on
levels
this
you've
scene?
already built, click here.
Yeah, I don't. Why don't I have that? I should have that. Hmm. Oh, that's not good. Oh. Alright, that's fine. Yeah, no, thank you. I've forgotten which keys are the ones that actually oh, Pyro, can you release that comment that on a mod? Whack that.
Hi there. Just type in your name and then we can play.
Yeah, I know.
Putting your
Need
name
to
in
switch
is as
scenes.
easy as pie.
It's gonna be a bad time.
You can use a keyboard or
Ah.
just click on the letters on the screen.
There we go. Okay. I forgot which keys on my macro keyboard switch scenes. It's been a while since I've needed to use them. Oh, okay. Oh, never mind. I misinterpreted the. Yeah, never mind. All right, so we got that. Excuse you. All right. So if I remember correctly, Pyro, I think I said there was like 120 levels. So we got like 3 left in here. I'm kind of curious to see what that actually entails. Yeah. Okay, that's what I
Are
thought.
you ready to play?
Yeah, I'm ready.
Prepare for takeoff, Pep.
Look at that! I didn't lose my power-ups. Awesome. I'm not gonna lie, I definitely thought I was gonna end up losing those. Now I know that this is only a limited power-up, it only sticks around for so long. But it's still nice, I still have it. Excellent. Well, yeah, there's also like, so you remind me of that picture of the deep space photograph that showed hundreds of thousands of galaxies. And it was like a full spectrum photo.
Let's get moving,
So
Pat.
it showed so much detail of that. I'm gonna have a terrible time on this map. Oh goodness. Why are they double ballooned? Oh no. Oh boy. Alright, we're gonna try our best to not, you know, explode here. No promises at this point. Oh no!
Come on, boy, let's have some more fun.
I made this so much more difficult for myself. I didn't realize that he would fly through the paint. That's what I anticipated. Oh, I'm gonna have a bad time. I'm actively having a bad time. Ooh! Come on now. I don't want to give the puppy brain damage. Oh, bugger.
Want to try again?
Oh yeah, the Pillars of Creation. I know which one you mean. That was neat. Trying to get him into that little gap. No, yeah, of course.
Ready to
It's gonna
pop
be
some
like
more
that.
balloons, Pep?
Pep, if you can hear me, thread the gap. You know what, hon? I'll have to check with him. Or actually, hon, check in my description. His link tree is posted. Double check and see if he changed it, because he would have likely have updated it there as well. Because if he didn't, I'm gonna have to update my description for him. Because he's a good bean. He does amazing work. I don't know how I caught him that time. Oh, that was close. Oh. Ah.
Guess this was kind of rough. Get it? Rough?
Yeah. I would expect these last couple to be fairly difficult.
Bet you want to play some more.
Sorry, Pyro. I'll have this conversation with him later. Oh, bugger.
Come on, let's do it.
Nope, I missed him.
Come on, let's do it.
Yeah, that was the name I last knew him by on the platform. He said unless he changed it. Alright, good. Yeah, I thought it was. imagine you're probably having a caching issue. Either that or it's just not loading on mobile. I mean, the platform just kind of funky stuff. Oh yeah, we got some bonuses. I'll take them. Oh, come on now. I believe! So my little friend here can get some frontward momentum. Come on. There we go. There we go. Got that last paint can. Got it!
Can you believe this, boy?
Being called out for not being able to spell. Yeah, no, I feel that. Pyro, don't feel bad. I sink in a similar boat. Alright, we've reached the final level. I'm curious to see what it's going to be. Oh boy. Oh, that's an interesting pattern we have here. Ah, missed it.
We can try this again later.
I mean, they kind of do, but yeah, I think it's going to require that power-up that appears in the upper right to be able to clear this. Because the way these are positioned and the way that the angles work in this game, I don't think that's going to really pan out too well.
Come on, let's do it!
Ah, bugger.
Ready to pop some more balloons, Pep?
Oh, that's so difficult.
Wow, that was a hard one.
We ain't giving up just yet.
Prepare for takeoff, Pep.
Prepare for trouble. Mega double. Ha ha. Bah.
You're a real trooper, Pep.
I was really hoping I could see if I could launch him at a tiny bit of an angle. I think I'd be able to drop one of these paint cans.
Ready to pop some more balloons, Pep?
Oi.
This was pretty tough, huh? Bet you want to play some more.
Yeah, I don't know. I mean, it's trying to get him. Into that gap.
Ready to pop some more balloons, Pep?
Alright, now that's progress.
Come on, boy.
If I can at least clear one of those 2 buckets, I think I'll be able to do it now. Oh, I saved that. Ah! Bugger, I lost it.
This again later.
I got the right idea, though.
Hot ziggity! Is this ever going to be fun?
Putt-putt, you have a strange idea of fun. You know what? I'll take it. I'm a red card now. It could potentially be because he hasn't streamed yet. The algorithm's kind of funky. I don't know. I'm gonna look at it myself when we're done here. Because that's obviously not good. Wow. Come on now.
Ready to pop some more balloons, Pep?
No, that's not easy. And we're rocking and we're rolling. If we can grab that power up, that'd be fantastic. Ooh. Okay, enjoy your night. Thank you for stopping in. Yeah, that's late. Come on! The power-up strip ran away. I want the power-up, please. I need it. I got it. Awesome. Power up cancels out the bouncy things. Which allows me to do that here!
Great job, Pep. Pep, you're the greatest balloon poppin' pup I know.
Oh, that was really hard. Oh my word. Excellent. I can't get over that. Seriously, what level of silliness does one have to present? Because somebody can record that in the studio. So, you know? I'm just saying. It's super silly, and I love it. I'm curious to see if we'll see anything here after the credits. Because I haven't technically finished this game before. I don't know, we're like gonna let this just marinate for a moment and see if we get anything. Because after 120 levels of time, that's just it. Someone was playing with a balloon in front of a microphone. That's where these noises would have come from. Humongous entertainment.
Do you want to play again?
You're a mad lad. No thank you, not right now. The best kind. That is obviously the answer to that question. The best kind of balloons. Not too shabby. Oh, fantastic. Alrighty. And with that, we're going to transition out for the evening. It was all a bunch of fun. I'm really looking forward to what comes next in our little kit of adventures here. I am amazed. Raid message. I don't really have one. That's a good question. I don't have brain power at this point. Let's do this. Photo. Ooh, I don't know if I'm gonna be fast enough. Ba 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 ba. Tita tita tita. I'm in trouble. I think it's gonna be misspelled, but I don't think I care. I don't think it's spelled right, but we can use that as a raid message. Alright, beans. See y'all next time. Bye-bye.
do that.
Raiders.